at synthetic division, synthetic division is actually a lot more straightforward than long division, but it is only useful in certain places. So the most important thing here is right here, and it essentially says that we can use synthetic division only when we are dividing by something as nice and clean as x minus a constant. So again, this only applies when we're dividing by something like x minus c. That's like something like, a polynomial divided by x minus 2 or x plus 4 or x minus 1/2. But if we were dividing by something like 2x minus 1, we would not be able to do synthetic. Synthetic only works for x plus or minus a constant term. So an example of this is here. Our first example is we're going to divide 3x cubed minus x squared plus 5x minus 3 by the very simple polynomial x minus 2. So first we're going to check that all of our powers of x are present. I've got x cubed, x squared, x to the first, and then a constant. And here I'm always going to have both terms. And so we don't have to fill in any missing values. So the first thing is that this right here is our c value. And I want to make sure my c value ends up on the outside. Now notice that it's always x minus c. And so if it's x minus 2 is what we're dividing by, it's a positive 2 that goes here. It's not a negative 2. It's a positive 2. So keep that in mind that it's always the opposite of what we're dividing by. And then we essentially fill in over here the numbers from our bigger polynomial. 3, -1, 5, and -3. So these are the coefficients, is what we call them, the numbers in front of the x's, the coefficients on our x terms. All right, so how does synthetic division work? It's actually pretty nice. So to set it up, I'm going to start by essentially drawing a bar a little below and putting a plus symbol. So I'm going to be putting some numbers in here and adding them together to get an answer at the bottom. My first step is actually to bring down the very first number. I always bring down that first number and immediately put it in the bottom. So the 3 comes all the way down, and I want to make sure my numbers are lined up really nice and clean so I don't get lost. And the next thing I do is I actually take this 3 and I multiply 2 by 3 and put the answer up here in the next slot. So 2 times 3 is 6. And so I'm going to put the number 6 here. Again, I take the number out here, my c value, 2 times the bottom number, and put the answer in the next space. Oops. 2 times the bottom number and put the answer in the next space. Then I do what it says. I take -1 and add it to 6. And that gets me 5. Then again, I'm going to take this 2, multiply it by 5, and add it to the next space. 2 times 5 is 10. And so I'm going to write the number 10 underneath the next number, underneath the 5. So 2 times 5 is 10. And then again, I follow the instructions by adding. 5 plus 10 is 15. Again, for the next one, I'll take 2, I'll multiply it by 15. I get positive 30. And I'm just going to add it again to the next row and add my numbers together to get 27. So that is actually the extent of the division work. And the last question is, how do we interpret this answer? What does 3, 5, 15, 27 actually mean? So first things first is that this final number, this is our remainder. Just like before, we often have remainders. And so our remainder in this case is the number 27. These 3 numbers are the coefficients on our answer. So we translate this into an answer. So where does this go? Our answer becomes, well, I've got 3, 5, and 15. Is it 3x squared, 3x to the 8th, 3x, just 3? How do we figure that out? I always think about that if my question is 3x cubed, my answer will be one power less than that. So 3x cubed means my answer here is just 3x squared. My next term is a positive 5, and I'm going to count down my x's. X squared goes down to x to the first, and then this 15 is just our constant. So 3x squared plus 5x plus 15, and then I have to deal with my remainder. And just like in long division, I'm going to write it as that fraction, 27, divided by whatever I divided by originally, x minus 2. All right, so that is one example. I do want to show you another one because I do think these can be a little tricky, especially in writing out these answers. So I'm going to scroll down. Feel free to pause the video if you want to catch up, but I'm going to scroll down and do this second example for you. So here we're looking at a slightly longer example. We're dividing f of x is 2x to the 5th minus x squared minus 1 by d of x equals x minus 1. So the first thing I'll check is what is the value of c? C is the opposite of -1, so c is just positive 1. And then I need to fill in all my different coefficients. Now, again, I've got to check if I have missing powers of x, and I skipped from x to the 5th to x squared, so I've definitely got some missing powers here. So 2 is first, and then I have whatever x to the 4th is, which we have is 0. After x to the 4th comes x to the 3rd. I also don't have an x to the 3rd. Then I get x squared, and x squared is -1. I've got that term up here. Then I get x to the 1st, or just x, and I don't have that either, so I have another 0. And then finally, I get my constant. So lots of numbers here, even though I only have 3 terms. All right, now I want to set up my layout here. So I'm going to add things together. And the first thing I always do is I want to bring down that first number. All right. So first thing I'm going to do, or second thing I'm going to do, I guess, as I start my multiplying and adding, is 1 times 2. So I'll kind of draw these gray lines again. 1 times 2 is 2. And I'll put it up here, 2. Then I take these two numbers and I add them together. 0 plus 2 is 2. Then I do it again. 1 times 2 is positive 2. So I'll add 2 here. And when I add them together, I get another 2. No surprise what's next. 1 times 2 is 2. Plop that here, but this time I'm adding it to -1, and so I come up with a positive 1. 1 times 1 is just 1. I'm adding it to 0. So I get a positive 1 again, and 1 times 1 is positive 1, and -1 plus positive 1 is 0. All right, so quick math at least, but now I have to do the work of interpreting my answer. First things first, this is my remainder. I actually don't have a remainder, which means we divided evenly, which is very nice. So my remainder equals 0. That's a lovely place to be. And this all in here become the coefficients on my answers. So my question started with x to the 5th, and so I should assume that my answer is going to start with x to the 4th, and I'll have an x to the 3rd, an x squared, an x, and a constant. So what are the coefficients here? Our first coefficient is 2, so 2x to the 4th plus 2x cubed plus 2x squared plus 1x, I'll leave it as x, plus 1. And that is my answer. All right, guys, good luck. Let me know if you want other examples, and that's it.